Means we're putting back together and we're fixing without parts from Bugatti, and we've already done and accomplished what we were told couldn't be done, which is give us.
This story is about a Bugatti rebuild project that has gone far beyond a normal repair job and turned into a global debate about engineering, responsibility, and modern car culture. At the center of it is a well-known builder, Matt Armstrong, who is known for taking damaged supercars and bringing them back to life in his own garage. But this time, the situation is different. This is not just about fixing a crashed hypercar. It has become a question of whether cars like this should even be rebuilt outside of factory control. From the very beginning, the project was expected to be extremely difficult, but nobody predicted it would turn into something this controversial. The moment the car started coming apart, people realized this was not going to be a simple restoration. It was going to challenge beliefs about what hypercars really are, how they are built, and who has the right to repair them. And that is where the real story begins, not with tools and parts, but with ideas and arguments that keep growing as the build continues. As the rebuild progressed, the biggest surprise was how normal some components actually were. Many people imagine a Bugatti as something completely alien, like every single part is custom-made, impossible to understand, and locked behind manufacturer's secrets. But once the teardown began, the reality looked very different. Some parts were complex, yes, but others were surprisingly familiar. This created the first wave of debate. If parts can be understood, repaired, or even replaced, then does that mean hypercars are not as untouchable as people believe? Or does it mean that skilled builders are simply more capable than most people assume? This question started dividing viewers into two groups. One group admired the skill and bravery involved in working on such an expensive and advanced machine outside factory conditions. The other group believed that without manufacturer control, something this valuable should never be opened or modified at all. This early stage set the tone for everything that followed, because it was no longer just a mechanical rebuild. It became a philosophical argument about control, expertise, and trust in engineering systems. One of the most important technical challenges came from the structural repairs. In most people's minds, a hypercar chassis is something extremely fragile and impossible to touch without factory machines. However, during this build, sections of the damaged structure turned out to be reparable with proper metalwork. Skilled fabricators treated it not as an untouchable artifact, but as engineered material that could be reshaped, welded, and restored. This moment changed the direction of the entire project. It showed that even the most advanced cars in the world are still built on physical principles that can be understood and applied. Heat, pressure, shaping, and alignment, all of these standard engineering methods still worked. But this also created discomfort for many viewers. If a hypercar chassis can be repaired in a garage, does that reduce its specialness? Or does it actually increase respect for the engineers who understand it deeply enough to rebuild it? The deeper the team went, the more the project stopped being about damage repair and started becoming about the limits of engineering authority. Another major turning point in the story came with the discovery of shared components, especially inside the safety systems. During disassembly, the team found that certain parts, such as airbags, appear to share similarities with systems used in more common vehicles. This led to even more debate online. Some people argue that this makes sense because many automotive groups share platforms and suppliers across different brands. Others were shocked that a multi-million-dollar hypercar could contain parts that seemed similar to those in everyday cars. This moment created a strong emotional reaction because it challenged the idea that hypercars are completely unique creations from top to bottom. Instead, it suggested that even the most exclusive vehicles in the world may still rely on shared engineering ecosystems. This does not make them less advanced, but it does make them more relatable in a strange way. However, the rebuild team still had to make a decision: trust the parts as designed or replace them entirely. Choosing to test and fit them successfully added another layer to the debate, because it showed that functionality often matters more than perception when safety systems are involved. As the rebuild moved forward, the interior transformation brought a completely different tone to the project. Unlike the mechanical sections, which were focused on precision and engineering, the interior became a space for creativity and personal expression. Instead of restoring the car strictly to factory specification, the team chose a bold custom design approach. New colors, patterns, and materials were introduced, changing the entire feel of the car's cabin. This decision divided opinions once again. Some viewers felt that this gave the car a unique identity and turned it into something even more special than before. Others believe that changing the original design of a hypercar reduces its authenticity and value. This conflict highlights a deeper question in car culture. Should rare cars always be preserved exactly as they were built, or is there value in reinterpretation and personalization? In this case, the rebuild clearly leaned toward creativity, showing that restoration does not always mean returning to the past. It can also mean reimagining the future of the machine. Cooling systems became another critical challenge, and this part of the build revealed how fragile performance systems can be when they are not supported by factory resources. Radiators and cooling components are essential for any high-performance engine, especially in a hypercar where heat management is extremely precise. Instead of ordering direct replacements, the team had to fabricate and adapt components using available materials and engineering experience. This introduced risk at every step, because even a small mistake could affect the entire performance system. When the system was finally assembled and tested, initial results looked promising, but then a leak appeared. This moment was important because it showed that even after successful fabrication, real-world pressure testing can reveal hidden weaknesses. It reminded everyone that engineering is not just about building something that looks correct. It must survive real stress conditions. The setback slowed progress, but it also proved that the rebuild process was honest and experimental, not guaranteed or controlled like factory production. Despite setbacks, the overall progress of the build remained impressive. The chassis had been restored, major systems were coming together, and the car was gradually returning to a functional state. However, the project was no longer just about whether the car would run again. It had evolved into something bigger, a public experiment in engineering transparency. Every stage of the rebuild was being watched, analyzed, and debated by viewers around the world. Some saw it as proof that modern cars are more reparable than people think. Others saw it as a warning that certain machines are meant to stay within manufacturer control. This dual interpretation is what keeps the discussion alive. It is not just about one Bugatti anymore. It is about the future of repair culture, access to information, and how much freedom independent engineers should have when working on highly advanced machines. In the background of all this, a larger cultural shift is also visible. Car enthusiasts today are no longer passive viewers of automotive engineering. Thanks to online platforms, they can watch entire rebuilds, analyze decisions, and form strong opinions about technical processes that were once hidden inside factories. This has created a new type of transparency in the automotive world, where knowledge is no longer limited to manufacturers alone. However, this transparency also brings tension because it challenges traditional boundaries of expertise. If something can be repaired outside the factory, does that reduce the authority of the manufacturer, or does it simply expand the role of skilled independent builders? There is no simple answer, which is why projects like this generate so much discussion. They sit right at the intersection of innovation, tradition, and public perception. Ultimately, the Bugatti rebuild is no longer just about fixing a damaged vehicle. It has become a symbol of how modern engineering is evolving in the age of content creation and global audiences. Every bolt removed, every part repaired, and every system tested adds to a larger conversation about what cars represent today. Are they sacred machines that should only be touched by their creators? Or are they complex but understandable systems that skilled engineers can bring back to life anywhere in the world? The rebuild does not give a final answer. Instead, it leaves viewers with a question that continues long after the video ends. And that uncertainty is exactly what makes the story powerful. It is not just about whether the car runs again. It is about who gets to decide how far engineering freedom should go as the rebuild continues beyond the early mechanical victories and setbacks. The project enters a phase where everything becomes more uncertain, more expensive in risk, and far more emotionally charged for both the builders and the audience watching unfold. At this stage, the car is no longer simply a damaged hypercar being repaired step by step. It is now a fully active experiment in real-world engineering limits, where every decision carries consequences that go beyond the garage. The work done by Matt Armstrong and his team starts to represent something bigger than a single vehicle. It becomes a test case for how far independent builders can go when working without direct manufacturer guidance, and whether skill and experience can genuinely replace factory-level systems. This is where the emotional pressure also increases, because the audience is no longer just watching progress. They are judging in real time, comparing against expectations of what a hypercar should be. And that expectation gap is where most of the tension in this stage comes from. Point one of the most critical ongoing challenges remains the uncertainty created by working without official support. In a factory environment, every repair step would normally follow strict procedures, with specialized tools, diagnostic systems, and original replacement parts designed specifically for the vehicle. But in this rebuild, the team has to rely on experience, problem-solving, and adaptation. That means every system, from wiring to hydraulics to structural alignment, must be carefully interpreted rather than simply replaced. This creates a constant balancing act between confidence and doubt. When something works, it feels like validation of the team's skill. But when something fails, like a pressure test or a cooling leak, it immediately raises questions about whether the approach is sustainable long-term. The pressure is not only technical but psychological, because every success raises expectations, and every failure attracts scrutiny from viewers who are deeply invested in the outcome. As the systems start coming together, attention shifts to integration, the moment where individual repair components must function as one complete machine. This is often the most difficult stage in any complex rebuild, because even if each part works individually, combining them can reveal hidden incompatibilities. Electrical systems must communicate correctly, sensors must calibrate properly, and mechanical parts must operate in perfect timing with each other. In a hypercar, this level of precision is extremely sensitive. A small misalignment or a minor calibration error can lead to performance issues or system warnings that prevent the car from functioning at all. This is why integration becomes a real test of whether the rebuild is truly successful or just visually complete. It is no longer about whether the car looks fixed. It is about whether it behaves like it was never damaged in the first place. At the same time, the broader debate around hypercar construction continues to grow stronger online. As more details emerge about shared engineering platforms and components that resemble those used in mass-produced vehicles, viewers begin to rethink what makes a hypercar truly special. The discovery that certain parts may have similarities with systems found in more common vehicles does not reduce the engineering achievement behind a hypercar, but does challenge the perception of total exclusivity. This leads to a deeper conversation about modern automotive manufacturing, where even the most advanced vehicles are often built within larger industrial ecosystems. This is not necessarily a weakness. It is actually a reflection of how complex and interconnected modern engineering has become. However, for enthusiasts who view hypercars as completely isolated masterpieces, this realization can feel surprising or even disappointing. It forces a shift in thinking from emotional admiration to technical understanding. Meanwhile, the physical rebuild continues to demand more creative problem-solving as new obstacles appear. Parts that cannot be sourced directly must be repaired, modified, or fabricated from scratch. This includes not only structural and mechanical components, but also smaller systems that still play critical roles in performance and safety. Every fabricated solution introduces a new level of uncertainty because it replaces factory-tested reliability with human-engineered adaptation. This is where experience becomes the most valuable tool in the entire process. The builders are not just following instructions. They are interpreting engineering logic under constraints. That interpretation is what allows progress to continue, but also means that every success carries a degree of risk that cannot be fully eliminated. The car becomes a collection of both original engineering and rebuilt interpretation, working together in a way that was never originally intended. As testing phases continue, the emotional weight of each result becomes more noticeable. When systems hold pressure, operate correctly, or pass a functional test, it creates a sense of breakthrough. But when something fails, like a leak or calibration error, it resets expectations and reminds everyone that the process is still incomplete. This cycle of progress and setback becomes a defining rhythm of the entire build. It reflects the reality of engineering work, where success is rarely linear and often comes after repeated correction and adjustment. For viewers, this unpredictability is part of what makes the project engaging. It feels real because it does not present perfection. It presents struggle, learning, and gradual improvement at this point in the rebuild. The conversation surrounding it becomes almost as important as the car itself. Supporters view the project as proof that skilled independent builders can achieve results once thought impossible outside factory environments. Critics, however, argue that certain machines should remain under manufacturer control due to complexity, safety, and long-term reliability concerns. Both perspectives highlight valid points, which is why the debate continues without resolution. The rebuild exists in a space where both admiration and skepticism can be justified at the same time. This tension is what keeps the story alive, because it does not offer a simple answer. Instead, it presents a real-world case where engineering capability and institutional control collide. As the project moves closer to completion, the final stages are no longer just about fixing what was broken. They are about proving that the entire system can survive real-world use after being reconstructed outside its original environment. This includes stress testing, performance validation, and long-term reliability checks that simulate real driving conditions. These final steps are where confidence is either confirmed or challenged. If the car performs successfully, it